Hi there. Today I'm going to show you how to do the wiring for one of my joystick bases here. Now your one may not look exactly the same as mine. I picked this one just because it's got a lot of buttons and dials and switches, and that makes it good for making a demonstration. I can show you how each thing is plugged in. So the first thing I'm going to do is just take that little joystick out because that's in my way. Now feel free to skip around in this video. If you don't have buttons, you can skip past the button parts and go straight to the parts that you do need. That won't hurt my feelings too much. So now I can pop that out. And now we can flip it upside down and keep it flat. And you can see we do indeed have a lot of buttons and pots and microcontrollers in here. Let's go through them one by one. Now first we've got 4 regular push button switches. Now these have 2 pins each, and one pin is going to go to ground and the other one will go to one of our points over here. So I'm pointing at ground there, and the second pin goes to a digital pin. And these guys, what they do is when you push the button, those 2 wires, they get connected, closing our circuit. Now, since 4 of these pins have to be connected to ground, we can actually join them all up together. All the pins that can connect to ground can all be folded into one ground. They're all going to the same place. So let me briefly explain how this circuit will work. So this little tag here, that's going to represent one of the input pins on our Arduino. Let's say that's pin number 9. Now this one detects an input between 0 and 5 volts. So anything above 5 volts has a danger of killing it, so don't do that. And it's got a crossover point somewhere in between, so it's something like once it gets over 1, 2 or 3 volts, it'll be considered on, or less than that, it'll be considered off, somewhere in the middle. But basically it's got 2 positions, 0 and 1, off and on. Now this little symbol here, that represents a switch, and you can see it's a little latch that can be open or closed. And the final thing we've got here is our ground connection. So a ground connection is basically somewhere that's 0 volts and current can flow freely to it. And I'll just actually add a little 5 volt source here, which is our current source at 5 volts. And the way we wire up our switches is simply like this. One side of the switch gets connected to ground, and the other side gets connected to our input pin there. Simple as that. Now, you may have seen a lot of the time, switch circuits have more components. Let me show you what you'll often see. Let me just draw this again with an input pin, a switch, a ground sink, and a 5 volt source. So often you'll see the switch like this, with the 5 volt connected to one side of the switch and the other side running through to our pin there. And so when the switch is closed, current can flow through from the 5 volts, and then we'll have 5 volts at our little pin there. But there's an issue with that. The 5 volts can flow in, but what actually happens is electrons flow in, and when we open the switch, the electrons actually have nowhere to go because the switch isn't really using it all. It all sits there, so it's like we've filled up the bucket, but the bucket's still full. So as soon as you turn that switch off, it's not going to switch to off. We're still going to detect that being on. And this is in fact what we call a floating voltage then. And even things like putting your hands near it or accidentally touching it, anything that can, even just electrons in the air, like static, can ruin that. So what we need is what's called a pull down circuit. And what we do is we just add one little resistor here, and he connects to ground, and the other end connects to there. So a resistor is just something that makes it a bit harder for current to flow through. But what happens is, when we turn our switch off, the current can still flow out. So when we close it, the current flows in and fills up that bucket. But then when we turn the switch off, it's able to flow back to the ground. So it's always flowing to ground, but because it's got that resistor, imagine you just have a small hole in the bucket, and that lets it gradually go out. Of course, this is not gradually going out. In our case, it still goes out super fast. It'll feel instant. But now we've got a switch that works. When we connect it, it'll flow in, and then when we disconnect it, it lets that current flow out and we'll have a 0 again. So you need a pull-down resistor and a pull-down circuit, I should say, to get nice input on a normal GPIO microcontroller setup. Now, the reason we don't need that with our Arduino is because it's actually got built in an internal pull-up resistor, or pull-up circuit, I should say, which is pretty much the opposite. So what we've actually got is internal to the microcontroller, there's a little resistor running down to 5 volts. And I'm not sure if, off the top of my head if it's 10K or 100K, doesn't matter too much, but what you have now is basically all the time you've got that 5 volts flowing in. And so this switch will actually be considered on by default. But as soon as we close that switch, the current, instead of going in through the resistor, instead of going into the GPIO pin and hanging around there, it all gets sunk down to ground, and then we'll be reading 0 volts at our pin 9. When the switch is up, we'll be reading 1, because we've got 5 volts, and when the switch is down, the current flows, emptying the bucket, and now we'll see 0 volts. So now we have a nice, clean on or off circuit. And it doesn't matter to us that it's on by default, because in software we can just say on equals off equals on. It really makes no difference. Now if we have a look at our wiring diagram here, you can see each switch has that left pin connected to the single ground, and they're all fused together first. And then each of the 4 extra pins, each goes to a different digital pin on the Arduino over on the left. So what we'll do is we'll first tie 4 of our ground pins together, and then individually we'll give each of them their connection to the Arduino inputs. So first I'm going to grab some black wire. Now the colors don't matter too much, but it's good to color code a little bit. So I'm going to use black for all my grounding wires. So I'm just going to roughly measure how long I need this to be. And this is just a short one because we're just going between those 4 pins. So I'm going to strip all the plastic off this one. There we go. So this is going to tie all our switches grounds together. So I'll just carefully connect all these guys. So just thread them through carefully. Keep it tightish and then just twist it off at the end. And before we go to the next step, we'll solder these guys. So about 380 degrees if you do have a settable temperature. But the main thing with soldering these switches is that you do want to get in and out as quick as you can. It's not that bad, but if the pins get too hot and the plastic begins to soften up, they can bend and you can lose the connection. It's pretty rare and you have to get it really hot to do it. But don't get these super hot and don't spend, more than sort of 10 seconds heating it up. Just heat it up, feed your solder in, and get out of there. And definitely don't try to move them around when they're hot. And just quickly have a look at those, and you can see they're all firmly connected now. So next, I'm going to run one of these ground connections to the actual ground on my Arduino there. So I'm just going to grab my black wire again. Just strip a little bit off the end. Whoops. There we go. Now that's about 6 millimeters I'm giving myself there. And that's quite long. And that's so I have enough to wrap it around and hold on tight right there. And I'll just roughly measure out how much I need. Always give myself a bit extra, because it's not going to hurt me to fold it up a little bit. And the other end just gets sort of between 1 and 2 millimeters, because that's just being soldered directly to a pin. So definitely much easier doing this with tweezers. And just anywhere between these 4 connections, I need to connect this. You could solder it right in the middle of that wire if you like, but I'm just picking a spot that feels easy to me. There we go. Once you've got it wrapped around, try and squeeze it on tight. And let's solder it before she falls off. So just heat it up, feed in some solder, give it a little tug, make sure it's in, and we're good. Let's do the other side. Now I'll flip this around so I have a better angle. So I'm just going to add a little bit of extra solder, just because having a bit of a bigger blob is going to be easier, and I don't think there's any flux in there either. So putting a nice little clean blob of solder will make this a bit easier. So you want to heat up the blob and let it melt, feed your wire in, take the heat away, give it a sec until it's cool, and then you should be good. So once that's tucked away, the next step is to do the next 4, and those will be our wires that go back to our input pins. And I'll do these, make sure you don't do these A0 through to A3, because they're going to be used for analog inputs, which is our potentiometers. But any of these numbered pins, except for 2 and 3, we can use as well. I'm going to use these 4 here. It's not what I had in the diagram before, so be aware of that, but it doesn't really matter. I'm using these ones just because they're closer, and it'll make my wires neater. So I'm going to use orange for this, and I'll make all 4 of them orange. Just roughly measure out the distance I need, and let's cut up some more. So same as before, I'm going to give myself about 1 millimeter on the end that goes to the Arduino, and about 6 millimeters on the one that goes to the switch, just so I can wrap it around and give myself a bit of mechanical strength there, and not just rely on the solder. So these just poke through the hole and fold that around. Whoops. And if you can wrap it around a little bit and have the wire sort of hold onto it with its own strength, that will be good. Right, so that one's on. Let's get the next one. There, now that they're all on, let's solder them all. So heat it up, feed the solder in. There we go. Looks pretty good to me. Give them all a little tug, just make sure they're not going to fall loose. Let's rotate it around. And let's connect these each one by one. So once again, I'm just going to add a little bit of extra solder to each of these. Now I screwed up a little bit there. I joined the 2 pins together with that blob. Not sure if you can see that there. So what we do is we just mount it and drag it through the middle, and we should be able to, that's it, separate those 2 blobs. Alright, now in no particular order, and I'll do it with the tweezers I think, so my big sausage fingers can't fit in there. We'll just do one at a time, heat up the blob. Once it's liquid, you can feed the wire in, take the heat away, let it cool down. Oops, I took it out too early then. Let's try again. And we're good that time. Let's do the next one. So get the wire lined up first. Melt the blob. Feed the wire in. Take the heat away. A few seconds to cool down. There we go. Alright, let's just finish the last of those. Tuck them up out of the way. That's looking pretty good to me. Alright, so next let's have a look at these toggle switches. Okay, now for our toggle switches, they work pretty much the same. But the diagram would be like this. So you have your switch, but instead of having just 1 possible position, you have 2. So that's our 1, 2, 3 pins. And actually I should say it's 1, 2, 3 pins. And what you would usually do is have this one connected to our ground, and this one, or this one, doesn't really matter, connected to, let's say, pin 4. And so when we're connected, we can see this one, because we're inverted, we're using an internal pull-up, this would be set to off right now. And if we switch this to the other position, this would now be connected to the internal pull-up and switch to on. Now, you can, of course, have a second input and have that connected there. And when it's switched to here, this one will detect it. When it's switched to here, this one will detect it. But there's absolutely no reason to do that, because you can always assume if this one's off, this one's on. So there are reasons to have these in other circuits, but for us, we just need to know if this is on or off, and that's enough to do it. Alright, so first I'll do my ground wires. And what I'll do is just roughly measure that out, so it's got plenty of room to go all the way around. Remember, always give yourself a bit extra. It's not going to hurt you to have it a bit too long. Very annoying to cut it too short and have to start over. So what I'm going to do, because those two switches are quite close to each other, I'm going to strip probably about 3 or 4 centimeters there. And that'll bridge between the two of them, just like we did with our 4 other switches. And what I'm going to do, I'm going to make my middle pin, which is pin number 2, like in our diagram earlier. That's going to be our ground. And then either the top or the bottom pin, which would be pins 1 or 3. It doesn't actually matter which of those is our signal pin, but we'll have one of those go back to our Arduino. So try and thread these through. There's a nice hole in the middle there. Sorry, I know the visibility is not great on this. I'm just fitting that through that middle hole there. Once I've got it, I'll wrap it around. There we go. Now let's grab the iron. And soldering this is identical to doing the switches earlier. Just heat it up. Feed in some solder until your wire is coated. Then take it away. Now the other end. He is going to our Arduino pad. So give yourself about 1 or 2 millimeters of bare wire. And this time, we'll use one of our 2 ground pins on the left. And once again, all the ground pins are connected internally. They're all identical. This is just a matter of keeping the wires neat. So give yourself some fresh solder there. And notice I've bent that wire, and that sort of hooks around and goes in there well. Simple as that. Alright, let's tuck him out of the way. Alright, and now for the 2 signal pins, I'll use orange again. So once again, just measure them out, just roughly. So strip a good 6 millimeters or so off the end that's going to go to the switch. And the end that goes to the Arduino just needs 1 or 2 millimeters. You actually don't want any more than that on the Arduino side. The reason being that if you have the wires sort of stripped and they're too long and they're all getting tangled up on the Arduino side, you're increasing your danger of shorting them and having them touch each other. So only make them as long as they need to be. Alright, so top or bottom, doesn't really matter. I think today I'll choose, I think the top I'll just have an easier time getting the iron in there with a little bit less risk of melting the side of my case there. So heat it up, feed in some solder, and when it's covered, take the heat away. And once again, let's hook these over. And these 2 digital pins in the corner, let's use those. And once again, just because they're the closest, and it will help the wiring be a bit neater. Alright, now those are connected. It is time to move on to our analog controls. So the potentiometer wiring is really simple. You've got 3 pins, 1, 2, 3. Ground. And your VCC, which is your 5 volts if you remember. And basically, you just connect 1 to ground, 1 to VCC. Now this doesn't actually matter, but it just has to be the 2 outside ones. 1 gets ground, 1 gets VCC. And the middle one gives you a signal. And so the signal goes to one of our analog pins, in this case, let's say A0. Now if you've got 2 of them, it's exactly the same. And what we can actually do is just wire these in parallel. So you see that's my ground, that's my VCC, and this one to A1. So you can have as many of these as you like, as long as all the grounds and the 5 volts can be chained together. But the middle pin, that signal pin, each one has to go to a different analog input on your Arduino. So let's go back to the real thing. And I'll start with this one on the left and just measure out my ground wire there. Give him a snip. And let's go into fast forward. So I'm just stripping the edge of the wire there. 6 mil on one side. Wrap him around on one there. This is a bit fiddly, but you get the hang of it. Just try and clamp it on there. Oops, dropped him. And once you can get it to hold. Oh, I dropped it again. What I'm going to do, I'm going to actually take this guy out altogether. And that'll make it a bit easier for me to get in there. So I'll pre-solder this one. And just hold it up like that. That won't be quite as strong as wrapping the wire around. So I'm just measuring my 5 volt wire. And I'll put that on pin 3. Now keep in mind, you can swap these, the black and the red. So long as that middle one is the signal pin, it's fine. And now I'm putting a second red wire on there, and I'm going to use that to daisy chain my 5 volt connection over to the next potentiometer. And we'll do the same thing with the black wire there. Oops, when I did the second one, the first one fell off. It's another reason why wrapping it's actually a good idea. So just run the black wire to there. Oops, sorry, that's the red one I should say. Wrap it around. Tack him on. Black wire, wrap him around. And because I'd pre-soldered that, I could just touch it with the iron. That's done now. So now let's do our signal wires. And I'm going to use purple for that. I'm just roughly measuring out how long they should be. And you definitely can't daisy chain these ones. Each one needs to go directly to an analog pin on the Arduino. Solder that on. And the next one. There we go. Now let's pop that back in. Tighten the screws again. And let's wire these guys up. So ground, I'm going to do to one of these ground pins on the left. For the signal, I'm going to send the first one to A0 and the next one to A1. And finally the 5 volts, that goes to your VCC pin. And that's it. Now the gimbal's all wired up. So next, I'll grab another set of wires, measure them out. And I'm going to put a nice big blob of solder on each of these. And just make that one my ground. 5 volts. Wire those two up. So I'll use the ground on this side this time, just because it's a bit better access. And now let's get a purple signal wire. So to the middle signal pin of the potentiometer. And finally, I'll just add a bit more solder to that third analog pin. So I'm wiring that to A2. Alright, and our last one is a bit further away. So I'll get my wires ready. I'll just put a nice big blob of solder on these. What I'm doing now is actually pushing it through that hole in the middle. So there's my ground, 5 volts, and the signal wire. And for the ground, 5 volts I should say. Let's wire that on there. Ground. And the signal that will take our final A3 analog pin. And that's it. All our controls are now connected. We've got our 4 buttons, our 4 potentiometers, and 2 toggle switches. Okay, now wiring up the communication line is not that difficult, but you do have to be careful and make sure you get it right. There's 4 pins. We've got 1 for ground, 1 for 5 volts, and there's 2 communications. The SDA, which is serial data, and SCL, which is serial clock. So if you're having a look at this one here, this is how I always try and remember it. Let's have a look at this bottom left one first. Now that one is our 5 volts. Now obviously when you're wiring it, you're connecting it to the opposite side. This is the part that plugs in. There's a big pad on the other side that you can connect to. This next one that is your ground. So that will provide power to the next board in the chain. Now for the 2 communication lines, I always tend to use the same colors just to make it easy for myself. So in purple, I would do the serial data. And in green, I will do the serial clock. And I apologize if that's getting a bit hard to see now. That's SCL. And the way these connect to the Arduino are as so. So number 2 is the SDA. Number 3 is your SCL. And I'm just going to label those here to make it a bit easy. So that's number 2. And that's pin number 3. And now your 5 volts is going to connect to your VCC. So that there is VCC. And the ground can go to any of our 3 ground pins. And for now, I'm just going to run it through here. And let's connect it to this one here. And so you can imagine by looking at this one, this is going to turn around and plug into that. And by the way, use this key at the bottom to know which way it is orientated. There's only the key on one side. Now, if you're wiring it to the opposite one, obviously it goes the other way around. So this one would be your GND. This one would be your 5 volts. We're looking at a mirror image here. This one would be your SDA. And this one would be your SCL. So just a mirror image flipped. And this one you can sort of see the pads on the bottom. So you can go, yep, that one's going to be the ground. This one here is going to be the red. And that's how you wire it. So, not too tricky, but it's not too difficult at the same time to accidentally flip these around the wrong way when you're wiring it from the back. But I'll put a nice diagram up so you can have a look at this later and to make it a bit harder to forget. So back in the real world now, I'll grab the stick and I'll just take that purple stick part from the bottom. And the first thing we need to do is make some wires. Now keep in mind these have to be long enough to come out from the microcontroller, run all the way through the stick, but you also want a fair bit of slack on this one because the stick's going to be moving. You need to make sure it can move all the way to each of the directions and preferably have a bit of extra slack as well. So I'll just rotate this to a more comfortable angle. Now what I'm going to actually do is rather than putting it directly on the board, I'm going to connect it to a 5 volt line I've already got running here to this potentiometer. Number one, it's closer, but also because my board's getting a bit high traffic now, there's a lot of wires going in there now. If I try and solder another wire, it's likely the other ones will pop off. So it's just a lot easier to wire it to this 5 volt connection here. Okay, now pins 2 and 3 are our SDA and SCL lines, so let's put a bit of extra solder on those. Grab my purple SDA line, mount the blob, feed the wire in, take the iron away, moment to cool, then we're good. So now I'll gather up all my wires and I'm just going to gently twist them and we'll feed that in through the bottom of the stick. And now we'll put the stick back in. And you've got to make sure the wires go nicely through the spherical bearing, but also make sure that sticks around the right way. Remember this one has that little hole pointing towards the user, so make sure that's in the right direction. So now let's strip probably about 3 or 4 millimeters from the ends of each of these. They're connecting to quite a large pad. So grab the top of the stick, there's a little set screw there to remove the plug, take him out. Now make sure you don't forget, as I've done once or twice, to put the stick back on first. So tighten up that set screw. There we go. Now, that's the plug. We want to find a nice way to hold it. I've got this little helping hand, so I'll use that. Now make sure you double check the wiring diagram before you do these up. And I've already put a blob of solder in each of these, so you'll have to feed a bit of solder in first. But you see then I'm just melting the solder, fitting the wire in, letting it cool down. And that's it. Try and make sure the wire is fully embedded in the solder. You don't want it sort of just sitting on the top. So flow the solder, stick him in. You can see the pin pulled through a bit there, so I'll just pull that back out again. And there we go, simple as that. So don't shove it in, carefully pull the wires back through, get it in position, twist and lock. And let's put the set screw back in. That's it, we can plug a stick straight into that now. And now we'll do the plug at the front, which connects to all the exact same spots. 5 volts ground, pins 2 and 3. Now I've got my wires ready. Just strip a bit off the ends. Right, now what I'm going to do first is just flow a bit of solder into each of these. Now if it is tricky to get in here, you can actually unscrew this and do it when it's not mounted. But I'm just going to go ahead and do it while it's in there. Now, sorry, I'm almost off camera there. So just putting on my purple wire there, my SDA, my green S clock, SCL, my ground, and 5 volts. Now my 5 volt line, I could plug that onto the board, but I think I'll just plug it onto this closer 5 volt line running to this potentiometer. Let's do the same thing with the ground. Like I said, with our SDA, that does have to go to pin 2, just like the one that runs to the stick. And the clock runs to pin number 3. And I'll just tuck those nicely out of the way. And that's it. She's done. We're completely wired up now. Make sure there's enough movement in that wire for the gimbal. And if you like, you can drop a bit of hot glue or blue tack to hold the wires in place, but otherwise, let's put that plate on and we can screw them closed. Of course, in reality, I'd recommend testing this out a bit before actually screwing the bottom on. But I haven't shown you guys how to put the bottom on yet, so let's go ahead and do that now. So I'm not tightening these screws up all the way yet. I'll get them all in nearly the way before I do the last bit of tightness. That's it, and let's go back and make them all nice and tight. That's the way, and then I've just got some nice little rubber feet I'll drop on there to stop him from sliding away. And there we go, we have our stick with all our buttons and dials and switches. Let's go do the firmware.